Okay, cool.
Can't wait.
So I will just get right into it here. And my name's Will Dorman. I am a professional bug magnet at the CERT Coordination Center. And this talk is kind of, the focus of this talk is about attacking COM via Microsoft Word. But before I get into the actual details, let's take a little trip down memory lane, which Dave might have alluded to a little bit earlier here. Think of the early days, maybe like 20 years ago. You've got your Internet Explorer 6, and you've got text, links, pictures, tables. That's kind of cool, but like we want a little bit more. We want something better. We want something a little more interactive. So I don't know if anybody remembers ActiveX. It was very big, we'll say 20 years ago. It started out before then. But the nice thing about it is it gives you an interactive web experience. So this is a very simple HTML page. All I'm doing here is I'm referencing a class ID for a particular object. And this is my rendered web page, which is pretty cool because I typed a little bit of text, but now I have this interactive sort of, I've got my real player, which I need to have that in my web page. So that's really cool to have that sort of interactive experience beyond just like your pictures and everything like that. The problem is it gives you an attack surface second to none. So think about code like 20 years ago. You've got C and C++ code written. When I say written by anyone, it's basically anybody can create an ActiveX control and release it. You can host it on your website. These are the days before you have DEP and ASLR, so exploitation is pretty damn easy. And the interesting thing about this, at least in the days of IE6, is all of this was exposed to any website being able to use without prompting. So you visit a website and it's like, boom, there, if I visit YouTube, the way that it implemented the video is it gave me an ActiveX control. So we released this tool years, I don't know, a million years ago, it seems, called Dranzer. And it will basically take an ActiveX control and it'll just try very simple things like, if you have something that takes a string parameter, it'll give it a long string. So here we can see we've got the real one player. The first thing it does is it just calls real player version. The very next thing it does is it calls this function called component version, or sorry, it does a property get. The component version property takes an argument of name and we give it a long string. What do we see here? Dranzer has logged an access violation at 787878. All right, bad read on 78s. If anybody knows their ASCII table, 78 is lowercase x. So we basically gave it a long string of lowercase x's and we now have an access violation. So let's think about this interactivity. Rather than my sample website where I'm just like putting this ActiveX control, I'm actually going to script it. So I can control it with the script section here. And I'm just going to call this component version with this variable that I call big string, and it's like a 10K long string. What happens when we load this page in Internet Explorer 6? We get our favorite 32-bit Windows debugger, immunity debugger, and I can see access violation while executing 78s. So if that, if anybody's ever done any crash analysis or trying to find bugs that they can exploit, like this is the biggest home run that you could possibly get ever. This was the world of, the web 20 years ago. Now, I mentioned in the prior slide that we have this ActiveX control that we are scripting. So, ActiveX controls and COM, but the two terms can be used kind of interchangeably, but basically take a COM object as the generic term for it. ActiveX is something that's designed to be used with Internet Explorer. And these objects can be marked safe to be used by Internet Explorer in one of two ways. You can have a control that is safe for scripting, which means that just like with that prior example where I showed the crash, I got a property and I gave it a really long string and it crashed in a very fun way. Safe for scripting. Safe for initialization with persistent data is vaguely similar in that it's a little bit less interactive, but you can still provide information, or you can provide data to that ActiveX control. Now, think about this for a second. How does Internet Explorer know, given any particular COM object that you're dealing with, how does Internet Explorer know if that object is safe to be scripted or initialized? How can it do it? I mean, a class ID is just a reference to registry value. How does a control specify if it is safe or not? And this is a thing that really didn't sit well with me for a bit, but in order for Internet Explorer to know if a control is safe or not, it asks the control, are you safe? And it says through its iObject safety interface, okay, yes, I'm safe for scripting. But in order for a control to answer the question of are you safe, the browser actually has to run code within that object. So it's a little bit of a chicken and an egg sort of situation. And what I noticed very early on, I think even before Drainzer existed as a tool, I was able to do some stuff with some basic scripting. And we basically have certain COM objects that kind of behave poorly. So this is a COM object. This is an HTML file. All it's doing is referencing a class ID. And what happens when I load that website? Access violation while executing some memory address, which happens to be in the heap sprayable realm of memory. So like, that's pretty bad. So we published a vulnerability note on this. Apply an update is to fix. Microsoft did a thing called a kill bit, which is basically a way you can disable an ActiveX control. Funny little aside about the kill bit, I kind of accidentally noticed at some point in time that if you put curly brackets around a class ID, Internet Explorer ignores that kill bit. So they fixed it eventually, but I thought it was kind of a hilarious sort of thing where I'm testing kill bits and it's like, wait, these don't work at all. Well, it turns out curly brackets. Anyway, so that's our history lesson. Let's think about modern computing. You probably have a Windows system, probably have Microsoft Office on it. The question that I have right now is, have we learned our lessons? This was a while ago. This is actually literally the email that I had sent to Microsoft a while ago. And I had noticed, I'm playing around with COM objects, and it's like, you can open up Word and you can embed Windows Media Player. And I noticed, if I take a doc and I embed Windows Media Player into it, like you get this, security warning saying, hey, some of this content is disabled. And the actual picture that you see there, that Windows Media Player, that was the Windows Media Player on the version of Windows that I used to construct the document. Not the actual version of Windows Media Player on the one that I used to view this document. So that basically it's like they're doing some things to protect you as a viewer of this document. What I also mentioned, so I'm just kind of saying, yeah, I'm guessing at some point Microsoft realized that you shouldn't be able to just embed objects without prompting. Let's take this exact same file and save it as an RTF. So here we've got the RTF version of it, and wait, that Windows Media Player is the actual version of Windows Media Player on my system. So it's actually running it. All I did is I opened up an RTF. It's running the code in that object. And I mentioned, I was like, well, so if you take the steps to restrict a document from just running an embedded object, you should probably do the same thing in RTF, right? This is November 10th, 2016. 5.5 years ago. Anyway, I didn't get any answer. And then I dug a little bit deeper, about 10 days later, I was like, hey, this might actually be a problem. If I have a COM object that doesn't opt into ASLR, somebody could use that as an ASLR bypass. They could use ROP and they could basically write an exploit for it. It's possible that there's certain COM objects that can cause a crash. Like back in the horrible IE6 days, there's certain objects that just referencing that causes a crash. The other thing that I did for kind of testing is I used the concept of an evil COM object. Just for my own testing, I wrote a COM object that basically spawns calc.exe when it's initialized just so that when I'm testing these sorts of environments, nothing bad happens. I mean, that's the standard sort of security researcher mindset is if you ever see calc pop up, like I hope you actually intended to run calc or some sort of shenanigans are going on. So Microsoft's response, they said, well, the difference between doc and RTF, it is not an indicator of a difference with how Word handles the control. We will proceed with closing this case. And that was November 28th, 2016, right? So I'm like, whatever. I'm busy enough with like a lot of the things that I'm doing at work that I easily get distracted and I start working on other stuff. So every now and then you get reminded of certain things. So there was a researcher, trying to think of when this was, a couple months ago, I think, maybe. Jonas L. had mentioned, hey, there's this global root path, and if you ever reference that path, it will crash Windows. And I started thinking, I was like, wait, when I was messing with RTFs, there was an aspect of that where you could like reference where that object was hosted. Like you can have an RTF or a document that references a locally stored object, or it could be a remotely stored object. So I tried, well, what if I take an RTF, and here I call it .doc, but whatever. I'm opening it in Outlook, my favorite email program. Oh, wait. All I did there is I previewed a document, and now my whole computer's crashed. That's bad. So that got me thinking a little bit. Well, let's revisit like RTF in Word, and what can you do with COM objects? So as I'm like looking for like, you know, I'm trying to figure out what's the best way that I can construct an RTF. I want to do it programmatically because I want to like generate for all COM objects. I don't want to have to use the Word interface. I actually found, this is text from a Google Project Zero report to Microsoft, and they say, hey, you can do a DLL planting attack, which is basically a DLL gets loaded from the current directory. And they had mentioned here, it's also, so their original report was about a document. They say it's also possible to trigger it with an RTF document, and they say without a user click. And this was October 21, 2015. So all this stuff that I'm talking about right now is essentially public since 2015. None of this is cutting edge, 0-day sort of stuff, but there are current behaviors that are kind of surprising. On December 8th, they closed it. Microsoft published CV 2015-6128, and they disabled this one particular COM object, and problem solved. We fixed it. Hey, everybody, let's celebrate. But based on this Google Project Zero report, I actually now have a template for creating my own RTFs. I added some line feeds here just to make it a little bit more readable as to like, you know, what is representing what. The only thing that really matters here is the part that's in yellow, and that's the class ID for a COM object. What do? Let's just make them all. Let's take our Windows system and let's make all of the RTFs. This is a subset of a Python script. In the end, it will give you just like a directory full of RTF documents. Each one is named for the class ID that it tries to instantiate. So I've got like, I don't know, 6,000. This is just a stock Windows system with Office, and I've got about 6,000 COM objects, 6,000 RTF documents. Here's another tool that we released that can actually help us automate that, and that's CertBFF, and that's our basic fuzzing framework. I basically specify my target that I want to run, and I specify the mode that I want to run the fuzzer in. And in this particular case, I don't care about fuzzing the documents. I just want to open them. So verify mode, all it does is it takes each seed file that you have, and it will try to open it and just see what happens. So I had noticed that some crash, BFF will put it in the bang exploitable categorization of these, and I can see, all right, probably not exploitable, read access violation near null. I don't really care. It's way different than the IE 6 days where it's like, hey, I've got an access violation trying to execute code at an address that I can get to. These are like kind of shrug worthy. But still, I've got RTFs that if I just open the RTF, it'll cause Word to crash. Every now and then I send out tweets about things. This was in response to Swift on Security mentioned something about process monitor, and I had basically said, you know, a process monitor is great for problem solving, but actually I can't even count the number of vulnerabilities that I found using nothing but process monitor. In this case, it's BFF plus process monitor, but there's a whole slew of ones. All you have to do is look at what a system is doing, and quite often you'll see things that are like, yeah, that's bad. So what do we do with our process monitor filter? Kind of along the lines of that DLL hijacking attack, I wanted to look for words trying to load files that didn't exist. So I just basically set a filter with two different things. You know, if the result contains no such or not found, then just tell me what's there. So let's look at what happens. You know, basically you run through the BFF routine. It opens your 6,000 documents. If process monitor is running while that campaign is going, it's kind of like log things that are unexpected. And these are basically unexpected file loads that I'm dealing with. So let's look at the first one here. This is from a product called Lotus Notes, which one might laugh and say, well, honestly, like who's running Lotus Notes these days? I will admit that 1 year ago today, CERT was using Lotus Notes in order to write up our vol notes and manage all of our tickets and doing everything. So yeah, we love living in the past. So here we can see our path. This has got an inproc server 32, which is basically like a library that Word will load into the process space when a document tries to reference it. So this, what's on the screen right now, is the actual RTF. The stuff at the very top is basically like text that I just have in the RTF just so I can look at it. And then there's, after that, it's referencing the class ID. What happens when we now open up this Word document? Again, we use our favorite friend, Process Monitor. And I could see, this is a document that I happen to have in my BFF directory, and I can see just by double clicking on this RTF, it tries to load a DLL called ndb2key.dll. Now, I don't necessarily know why it's loading that, but if I see a DLL being loaded, then, or attempted to be loaded, it's suspicious. So let's actually plant that DLL there. So here I just placed, in this case, I moved it to temp/interesting, but I created a DLL that just launches calc. And well, there we go. There's WinWord creating a calc.exe process. What triggered that? It's just an RTF that references a class ID. Nothing more. Nothing more. Let's dig a little bit deeper. Here's a component that comes with a particular Python package called PyWin32. Here, it doesn't specify a full path, but maybe that's good enough because it's in a system-wide path. But it's just called Python ComLoader 27. Here's a little bit different. I can see at the top there, it's trying to load something from /lib, which on the Windows platform is c:/lib, so that doesn't exist. Here I can see, in this case, I'm loading it from the seed files directory. It tries to load a Python script called site customize.py. Let's try placing our own Python file there. 2 lines, import os.systemcalc. See what happens. We open up our document, it sees site customize, and now I can see there's my calc.exe. Similar sort of thing. All I'm doing is opening an RTF, references a class ID, and now I've got code execution. Now this Python script, I mean, I'm just doing os.systemcalc. I could do something a little bit more interesting if I wanted, but you know, like I said, security researchers stop at popping calc. So that's enough to show that there's something of interest here. Now, here's another one. This one was a little bit more interesting. It kind of piqued my curiosity a little bit more. Here's something that comes with Microsoft Office Click to Run, and it's from System32. It's trying to load an exe, which is rather than inproc server 32, this is using local server 32, which means it's an actual executable that provides the COM object, does all the dirty work. When I load this document from the temp directory, it looks for a file called .exe. That's like even more interesting than a DLL. Like, why would Word be looking for, or sorry, why would Windows be looking for an exe file if not to run it? Now let's try it. Let's place a file called .exe. In this case, I just copied calc.exe, and I can see based on the icon there, yeah, okay, it's running that file called .exe. Let's look a little bit deeper into like this COM object server, this local server, vd_sldr.exe. If I go into the registry, I can see, okay, system32 vd_sldr.exe. It happens to be in WoW 6432 node, so that basically means this is a 32-bit app, and when a 32-bit app asks for system32, it's going to give it a little bit of a different directory. It'll give it syswow64. Let's look at that file. It's not there. Huh. Well, how is it that a COM object server can cause Windows to look for .exe, but the COM object server isn't actually there? So I dug a little bit deeper, and I realized, well, it's actually nothing about that particular COM object that is at fault. I just created a class ID deadbeef, and then I had this. I basically said the local server is c:/does-not-exist.exe. Let's look at what happens when I open the RTF. It looks to see, okay, is c:/does-not-exist.exe? Is it there? No, it's not there. I'm going to try harder. If c:/does-not-exist.exe is there, what about c:/does-not-exist.exe dash embedding? Now is it there? Still not there. I give up. I'm just going to run .exe. Why not? Look a little bit deeper into the call trace, and this is all from Process Monitor. Yeah, it's a great tool. Based on any activity that happens on Windows, I can look at the call stack and see, okay, well, what led to me doing this? And I can see, okay, this is Microsoft, click to run, the way that they package Office recently. This actually was just addressed last week, March 9th, 2021. I think that was a week and a day ago. They give me credit. Yay, let's celebrate. So they addressed the one variant that I've demonstrated so far where Windows or Microsoft Word will try to run .exe. They didn't change anything else about how Microsoft Office operates. It will still try to instantiate any COM object when you open an RTF document. So they basically, rather than addressing the class of a problem, saying, hey, you probably shouldn't instantiate COM objects without, maybe asking the user, rather than addressing the class of vulnerabilities, they said, you know what, I'm going to solve this. I'm going to fix just that one COM object, or that one class of COM object for a thing that doesn't exist. So let's look at attack vectors. One of the things that we do as like a vulnerability analyst is we want to look, okay, you find the underlying vulnerabilities. What are the ways that you can trigger that vulnerability? So let's look at a couple ways that you can trigger an RTF document. And the general idea for this whole class of issues is you have a same file, you have a malicious file in the same directory as the document that you're trying to open up. So that's the general thing that we're trying to achieve. The very simplest way is like, well, what if you just put it on a network share, like an SMB link? It's very simple. It's not practical because I probably don't use computers in the way that most people use computers, but I don't often visit SMB servers that I don't trust. Although if it's a shared work network share and every person in the company is using that, then I'd probably be skeptical about opening stuff up direct from it. So let's look at this. Let's take our Windows XP. Looks like I made this just 1 month ago, so this is timely. So what am I going to do? I'm going to run, and I'm going to go to / attacker SMB. Okay, here's my LOL RTF. I'm going to click on it, and there's my Windows XP version of calc. Didn't I just say that there needed to be another file in that same directory? Well, there is, but Windows very helpfully by default will hide files that say that they want to be hidden. So the default behavior with Windows is anything that says that it's hidden, it just won't show it to you. Kind of in the same way that it doesn't show you the file extension because Microsoft has decided that this makes people, makes it easier to use Windows. I don't know. Security folks have different expectations as to what is reasonable versus like the real world unwashed masses. Another thing that I ran into, this is a thing that I've talking about like what security people think is reasonable and what regular people think is reasonable. I've noticed any browser based on Chromium, it will automatically download a file without asking you. I thought that was odd, and I told Google about it years ago, and they said, no, we need that. If you visit a website with a Chromium-based browser, it's possible that that website could plant on your hard drive a file without you even knowing about it. Yeah, maybe if you look at it or you're paying close attention because you're aware of your surroundings, maybe you'll notice. One thing about this is you have to click out of protected view. And also, in order for this file to be downloaded without prompting, Chrome has to consider it safe. There's a whole lot of things that it'll still download. So here we got a video. And this basically, rather than viewing an SMB location, I'm just going to attacker.example.com. Now notice, I just visited the website and it already planted a PYC file. Okay, now, I want this RTF document. I open it. One thing that's interesting here is Office opens in protected view. I click enable editing and oops, I own it.txt. Something really bad happened there. So yeah, it requires a little bit of user interaction. Let's consider another popular web browser, Firefox. If the target platform has Office 2013 or earlier, if you have a document that has an embedded package in it, and that's basically, if you have a document and you drag calc.exe into it or do whatever, it stores it as a package object. With Office 2013 or earlier, it will, when you open that document, it'll automatically extract those to your temp environment variable. Firefox, on the other hand, when you open a file from a web page directly, it'll open it in the %temp, same directory. What happens if you combine these two? Again, you have to exit protected view, but let's take a look at this. Here I'm going to my attacker's website using Firefox. All I'm doing is I'm opening up an RTF. I'm doing nothing else. I would like to enable editing, sure, because whatever, protected view. I click it and now I've got compromised. That's pretty bad. Now, how does this protected view even work? How does Windows know when it opens up a document like it's actually something that came from the internet? If I do a directory listing of this file that I downloaded, lol.rtf, I just see the file there, right? But let's try something else. Let's do a dir/R. And if this is an NTFS file system, it has a thing called alternate data streams. And I can actually see here, there's not only the document, but there's also an alternate data stream that specifies information about that thing that I downloaded. And it turns out you can actually just open up that alternate data stream. It's a text file. You can just say Notepad, okay, I'm going to look at that. And now I can see right here, I just have a file that I've downloaded onto my system, but it also has this alternate data stream that says, okay, zone ID is 3, that's the internet zone. So basically, any Windows app that is buying into the whole mark of the web sort of thing, it can see that, okay, this is a dangerous file. But now, as we security researchers do, we got to figure out, well, there's got to be a way to bypass the mark of the web. That alternate data stream is placed there if I use like the built-in Windows unzipping capability. If I use like a third-party archiving program, it might not choose to place that mark of the web there. So if I use 7-zip, it doesn't have to be an actual 7-zip archive. I could just, open a zip file with 7-zip. If I extract that, no mark of the web. That's kind of nice. If I look at VHD or VHDX contents, those are a virtual hard drive. And then the modern version of virtual hard drive. The contents of those are not tagged with the mark of the web that the container has. The problem with that is it requires that the user is an admin. I didn't notice this because like this is an automatic elevation that Windows does. If you are logged into your computer as an admin, which that's a bold thing to do. If you're logged into Windows as an admin, it will just automatically, you can double click on a VHD or a VHDX. I did a blog about this in 2019. Go ahead and use your favorite search engine to find that. What I found is interesting is an ISO or an IMG. They're both handled by the same handler in Windows, and that's basically like a CD image. Your ISO 9660. When I double click an ISO or an IMG, it'll open up, it'll mount it as if it's a CD, and I can view the contents of it. So let's look and consider about an RTF in an ISO file. I don't need admin privs, there's no mark of the web for the contents, and as Windows conveniently does for you, it hides files that say that they should be hidden. So let's look at this example here. Viewing my website, it automatically downloads an ISO file. Okay, whatever. Here's an RTF. I'm going to click on it, and I just got compromised. All I did so far is I opened an ISO file and I double clicked on an RTF. Nothing else. I didn't exit protected view. Protected view never came into play. That's pretty bad. So just to kind of wrap things up, let's talk about defenses. And I think I'm pretty close to on schedule. What can we do to protect against this? Microsoft fixed just last week, just one of these attack vectors, or not one of the attack vectors, but they fixed one of the target COM payloads, which is an exe server that doesn't exist. What can we do? What can we do if we're in charge of defending systems? One thing that you could potentially do is look at your workflows and see, do we have a work need to receive RTF files? I find them to be pretty uncommon. The one thing that you need to consider is it's not just the extension .rtf. If you think about the video that I played earlier, that was a thing that had a .doc extension. You double click on a .doc, it says, okay, Windows says I'm going to open that in Word. It opens it in Word. Word says, oh, okay, that's an RTF. So you can't just base, with the way that Windows works, for most cases, you can't just base blocking on extensions. You would have to look at the file content. The other thing that you could do, I personally, I don't see a legitimate workflow for this, but right now, probably most people have the ability to receive over email a VHD, VHDX, ISO, or an IMG file. If you're operating an email gateway, I would say probably turn those off. The other thing that I mentioned in my blog post about VHD and VHDX files is there's no antivirus product that will scan on the wire the contents of a VHD. So I could put Mimikatz in a VHD and email it to you, and nothing would detect it until you actually mounted it and then Windows looked at the contents of it. So it seems like a high-risk sort of thing to allow that. The other thing that you can do, rather than just focusing on the email attack vector, is in Windows, you can change with file associations, and I can say, okay, well, none of my employees ever have the need to double click on a VHD, so I'm just going to associate that with nothing. So if I double click on a VHD or an ISO, nothing happens. Now, if I am in your IT department and I need to mount a VHD, okay, well, I'll go to computer management, I'll go to disk management, and I'll say mount VHD, and I could still do it. It doesn't actually prevent me from doing my job as an IT person, but it prevents your less aware of how computers work employee from double clicking on something and something bad happening. The other thing that I mentioned earlier is Office 2013 and earlier does an unsafe extracting of embedded packages. It uses the temp directory. Starting with Office 2016 and newer, it will extract it to like a unique GUID subdirectory of there. So Microsoft has realized, wait, we should probably do something about that. If you're using a Chromium-based web browser, and that includes the new version of Edge or Chrome or Chromium, there is a preference to turn off auto download. Please turn that off. I can't think of anybody that is annoyed / bothered by the fact that they have to like say, yes, I really do want to download that file that this random website wants to put on my computer. And finally, just to wrap things all up, if there's one thing that I've learned in my years at the CertCC is, this is a very good example of it. The more COM that is installed on your system, the larger your attack surface is. But that happens, that basically that idea, that mindset can be applied towards anything on any system that you ever use. The more software you have on your system, the larger your attack surface is. So if you ever are in a situation where you want to solve a problem and your solution to increase your security is to put more software on your computer, I would think twice about that. And that is it. I will be hanging out in the chat. Feel free to send me a tweet. But thank you much.
Boom. Back. We're back.
That was great.
I told you, Dave. ActiveX. You thought it went away 20 years ago. Get real.
Unless you live in Korea or use government systems, I guess.
Oh yes, it's everywhere.
Can't
I was talking with Dave about format string vulnerabilities yesterday, so nothing ever goes away.
No, we live in an endless cycle of pain, which I enjoy. So one of the questions I had, because we have just like a couple minutes, is can't I create a ISO partition on a USB drive and then throw those around and like make something like super interesting as the RTF file name? Would that just work? Should I start doing that right now, like after this phone call?
What you could do, if you're putting things on a thumb drive, there's two things that you can do. Is you can put the RTF and its payload directly on the file system of the USB drive, and if somebody plugs it in, they'll have to double click on the RTF and open it. If you put an ISO file on a USB drive, when they plug it in, Windows will, depending on how you have Windows configured, it might pop up with Windows Explorer, and it'll just give you that ISO file, and then it's up to you as the user to double click on it to mount it. So I don't know if there's anything that's really fully automated. The best thing that I don't know if you still have my screen sharing, but the thing that is probably the best example was the ISO file. The example that I had was basically downloading it from a website. I could email an ISO to somebody. I don't think they generally have that disabled. All it requires is you double click on the ISO, that mounts it. You double click on the RTF, and then that's it. That's game over. And those, in my mind, part of like when you're thinking about the viability or the plausibility of certain attack vectors, part of what you have to do is think about, is this an activity that a user would likely do? And these both seem pretty reasonable. Once you get into the point, and I've talked with Microsoft about this, and you can embed things into Word documents. I can embed an exe in the Word document, and if I have to click out of protected view, and then I have to click past that dialog that says, hey, we're about to do a thing, do you want to do that? They're kind of in the point of, well, we don't care. You as the end user have clicked through that dialog, so you as the end user have decided, I want the malware that document is giving me.
So I guess there's one thing I really liked about this technique is when something's executing inside of WinWord, you have to assume it's probably not going to be looked at by an endpoint protection system of the type that there are so many of in the world right now. It's just a DLL. It happens to be loaded into that space, and there's just not like a lot you can do about that.
This is Microsoft Word behaving in the way that it was designed to operate. And unless you are really certain, and unless you're actually looking, these things will probably go unnoticed. I just happen to have Process Monitor open while I'm doing my BFF campaign. And when I saw it try to load a file called .exe, that's the That's where your security researcher flags all go off. Like that's not right.
Okay, so I have a bunch more questions. We're going to probably roll those in the Discord chat, which you promised you would be attending.
I will hang out in
The
Discord.
expert channel.